Hello and welcome to Math Tape 061, Evaluating Variable Expressions. We're going to work with variable expressions in many ways as we go through this entire unit. In this particular tape, we simply evaluate the expressions. As you watch the tape, take careful notes. In any place that you don't understand what I explain to you, or any place that you make a mistake in the exercises I shall give you, be sure to mark your paper so that you can ask questions from a lab instructor or a tutor when you go to the lab. Our sole objective in this tape is to evaluate variable expressions. To begin with, we need to define the terms that we'll be using in this unit, so let's start with our definitions. The first definition is for variable. A variable is a letter used to stand for a quantity that is unknown or that can change. A variable is a letter used to stand for a quantity that is unknown or that can change. A letter, the letter may be any letter of the alphabet theoretically. In mathematics, we often choose as our variable a letter that makes sense for the expression that is unknown. For instance, if the expression that we're working with is time, which obviously can change, we often use the letter t. So the variable might be the letter t. If we're working with the length of a rectangle, we might use the letter L. If we're working with velocity, we might use the letter V. If we're working with an unknown number, and we're simply told that it is a number, perhaps the letter N would be chosen. When there's no particular reason to choose one letter over another, the all-time favorite choice is the letter X. The letter X is chosen because X does not begin very many words in the English language, and it is less confusing to use the letter X than many of the other letters. For instance, notice how I wrote the letter L. If I wrote a print L, it might look like the letter 1. If I wrote the T without the little curl on the end of it, it might look like a plus sign. The X has a slight disadvantage, you would think, because of multiplication. But we avoid that by using other symbols for multiplication. So X is the all-time favorite choice of variable if there's no reason to choose something different. Let's next define a variable expression. A variable expression is an expression that contains one or more variables. A variable expression is an expression that contains one or more variables. A variable expression might be simply the letter X. Or it might be, let's say, 3x subtract y. That's a variable expression. Or it might be negative 2/3 ab to the 4th power. That's a variable expression. A variable expression is an expression that contains one or more variables. Our third definition is term. A term is a number or a variable or a product of numbers and variables. A term is a number or a variable or a product of numbers and variables. Terms are the add-ins of an expression. Terms are the add-ins of an expression. A term is a number or a variable, or a product of numbers and variables. Terms are the add-ins of an expression. Let's look at an example. Three xy plus x squared subtract y plus 6. Terms are the add-ins of an expression. What things are being added here? Well, clearly we have addition in this spot, and we have addition in this spot. What about subtraction? Well, we know that to subtract an expression, we add its opposite. And so, we can think of this as, in disguise, add the opposite of y, which means that we have 4 terms. 3xy plus x squared minus y plus 6 has 4 terms. Each term in an expression has different parts. Each variable term is composed of a numerical coefficient and a variable part. Each variable term is composed of a numerical coefficient and a variable part. For instance, our first term, 3xy, is composed of the numerical coefficient 3 and the variable part xy. Well, let's list for each term in our expression, let's list its coefficient and its variable part. The first term is 3xy. Its coefficient is 3. Its variable part is xy. The second term in our expression is x squared. X squared has no numerical coefficient showing. However, we know that x squared means 1x squared. Therefore, the coefficient is understood to be 1, and the variable part is x squared. For the term minus y, remember that in the original expression we had 3xy plus x squared minus y, which we can write as plus the opposite of y. Therefore, we call this term minus y, or opposite of y. So here's our term, minus y. Its coefficient, likewise, is understood to be a 1 in front of the y, but because of the minus sign, its coefficient is negative 1, and the variable part is y. Notice that the sign on this expression goes with the coefficient rather than with the variable part. Finally, the term 6, coefficient and variable part. Well, we notice right away there is no variable part. Do we call 6 the coefficient? Well, we can. However, it is more commonly described as simply a constant term. 6 is a constant term. Constant term as opposed to variable term. The 6 is constant throughout the entire problem. A number does not change. It is not unknown. Therefore, it is not variable. And so it's called constant. The 6 is a constant term.